And welcome back to our final day of midterm prep. We are into proofs now. Some short answer questions. And number 54 is where we left off. So if you look at what it asks you to prove, notice that it does not ask you to prove triangles congruent. It asks you to prove parts of triangles congruent. So we've taught you that when that happens, you're headed towards CPCTC at the very end. So first we have to prove the triangles congruent. So let's get our givens down. And it doesn't matter how you organize the givens as long as they're all there. We chose to put it on two separate lines, but don't get hung up on the numbers of the lines because you could group things differently. So there's all my givens, and now I'm going to mark the picture. BD bisects, so it's saying this bisects angle ABC, which is going to lead to that being true. And then it says BD is also perpendicular to AC, which means those two angles are 90, and they're going to be the same. So the next thing you can say after the angle bisector right here, that leads, I'm going to sneak this in there first anyway, BD reflexive. That should jump out at you right away. So we have the reflexive side in the middle, so we have an S right there. Then angle 1, which I'm going to call this 1 and this 2, angle 1 is congruent to angle 2. And why is that true? That rhymed. Because of that. Because if it was bisected, the ABC angle was bisected by BD, then those two angles are equal to each other. So we say that a bisector leads to two congruent angles, or implies two congruent angles. Next, angle 3 and 4, which I'm going to call these guys right here, 3 and 4 are both right angles. Why are they right angles? Because, I lost part of the word there, because perpendicular lines imply right angles. They lead to two right angles. I never said that 3 and 4 were equal to each other yet, so I'll say it now. So 3 and 4 are equal to each other because all right angles are equal to each other. So now I think I have enough congruences. If you notice, I have 1, 2, 3, and that's usually enough. And I have a side, looks like I have an angle, and I have an angle. Now don't trust this order. Go up to your picture and see what we have here. Looks like I have an angle, side, angle situation. So that means that the two triangles are congruent to each other because of angle, side angle. Once the triangles are congruent to each other, all other parts that we haven't talked about yet are congruent to each other if they correspond. So AB is now going to be congruent to CB because corresponding parts of congruent triangles are congruent.
All right, we're back with our next question, number 55. And as you notice, I put on some Justin Timberlake, a close friend, because we're going to be talking about a bow tie question. So if you look at the little picture right here, I drew Mr. Fields, and he's wearing a bow tie. So a lot of my kiddos, I talk about this a lot. If you have a bow tie problem, which we do here, you're always going to have our friend vertical angles. So before I even jump into this question, just want to remind you all, when you have a bow tie, it could be this way, or you could flip it sideways, sort of like here. Make sure you look for those vertical angles and mark them right off the bat. So this is a little bit of a trickier proof because if we look at our proof statement here, we're told to prove that lines are parallel. How are we going to do that? Well, almost all the time, 99.9% of the time, when we have parallel lines in a proof, it is going to somehow relate to alternate interior angles.
That's what I've heard.
Yeah. So I'm going to show you how we do that. But first, we're going to start by showing this polka dotty triangle is congruent to this stripy triangle. So we already have our friend, the vertical angles, and I've written our givens. So I put our givens, and then we have angle 1 congruent to angle 2, because vertical angles are always congruent. Now, as soon as I see that we have an angle here, I'm going to go up to my little checklist of 5 ways to show that triangles are congruent, and I'm going to cross off which one.
I'm going to say ones without A's.
Bingo. SSS.
Good.
And we don't see anything about right angles here, so see ya by HL.
Down to 3.
All right. Now we have to use this fact. We have triangles. That helps us to show that we have our vertical angles. And then we have this word midpoint. Now, if you have a word in the given, it should show up somewhere here in our column. So what does a midpoint do? Well, a midpoint cuts a line segment into two pieces. And this midpoint is great because it's not just cutting one segment, it's cutting two. So this is going to give us two sides that are congruent. AC, let me use a different color. AC is congruent to EC. CD is congruent to BC. So if we look down here, okay, so now we have a lot of good stuff here. So as Mr. Fields pointed out, we've got 1, 2, 3 things. We have a side and a side. Uh-oh, now I'm swearing.
But don't trust the order. Go up and see what it looks like in the picture.
And actually, if we're using the checklist, what's even nicer is we can look here and see that we have two sides. So it can't be that. It can't be that. It has to be this. But still check in the picture, right? Angle 1 and angle 2. Is that touching both the congruent sides? Bada bing, bada boom. It is. So now we can say the triangles are congruent by side angle side. But, Mr. Fields, we forgot. How are we showing that these lines are parallel?
Well, you mentioned something about alternate interior angles. Tell me more.
Oh, well, I'm glad you asked. So I'm going to put a little 3 and a little 4 here.
Okay.
And when we do that, because of our old friend CPCTC,
okay.
we know these angles have to be congruent. And if we look at those angles are alternate interior. So I'm first going to start by saying angle 3 and angle 4 are congruent because they're corresponding.
Okay, I see where you're going with this.
Now, if we have alternate interior angles congruent, which we already said we do, we're now going to put 3 and 4 congruent. Since those are alternate interior angles, that means these two lines here have to be parallel. So we're going to finish off the proof. Done, done.
Alternate interior angles lead to parallel lines. Okay,
Yay.
got it.
Perfect.
Thank you. The iPad, I can't show you the actual compass maneuvers, but in order to create an equilateral triangle or a hexagon, either one, you take your straight edge and you draw a radius. Then you put your compass right there on that blue dot and you make an arc upward like that. Then you move to this spot, you keep the compass the same, and you make another arc, and you kind of chase your way around. 3, 4, 5, and 6 should bring you back home. If you wanted to make a hexagon, you would connect all 6. But an equilateral triangle, you pick every other one, doesn't matter where you start, and you have constructed an equilateral triangle. Now, as far as a square, you're going to go all the way across with your straight edge and draw a diameter.
Ooh, diameter.
Diameter. 2 radii, if you will.
Oh.
A diameter has 2 endpoints. Now, we do the perpendicular bisector popular construction by putting our compass at one side and measuring more than half, and then flipping it over and doing the same thing on the other side. And that creates a perpendicular bisector, which is another diameter. But what it really does is gives us 4 corners of our square. 1, 2, 3, 4. And with your straight edge, you complete your square right there. Take a look at number 3. Based on this picture, we have parallel lines cut by a couple different transversals. And let's figure out everything we know here. 30 is vertical with this, so that would be 30 as well. 70 is vertical here, so that would be 70 there. Now you also have another 30. You have 2 parallel lines cut by a transversal, so this and this are alternate interior, so that would be 30. So you can look, one way to do this is look at this triangle here, and you know that triangles add up to 180 degrees inside. And inside that triangle so far, we have 30 and 70, so that has to be 80, so it adds up to 180. The question says, explain why x equals 80 degrees. What you could say, anytime it says explain, you have to use words. So you could explain that the 30 was alternate interior, the 70 was vertical, and triangles add up to 180 degrees, so 70 plus 30 plus 80 equals 180. As long as you get the point across, and have evidence, you're good.
Okay, we're back on page 15, number 4, and we're looking at reflecting over the line y equals -2. So just a reminder that y equals -2 is going to cut through the y-axis at -2. We can count the boxes from A and then count down to A prime, and we'll flip over. Now the key part here is explain why. Why is this congruent? So here's where you want to mention a reflection is a rigid motion, since size and shape are preserved. And that will definitely show up on the Regents as well as our midterm.
Most likely.
Yep. And then a sequence of rigid motion. So with this one here, what I would suggest we do is look to see like point C and point R match up, as well as points T and point G. So pick some of those points, actually pull those points out. So T, -2, 5, and I found that G was 2, -5. And if you look at these, you'll notice that what they did was they just flipped. So -2 became 2, 5 became -2. And if you also take and switch these, you'll notice that it moves 2 quadrants. So it's rotating 180 degrees about the origin. So for number 6, we have a sequence of transformations. So when you see this sequence, it means most likely there's going to be more than one. So our first thing, and again, it's important to note that when you're doing a sequence of transformations, there's actually a ton of different ways. This is just one suggestion. But what I first did was I started with triangle ABC right here, and I reflected it over the x-axis. So I'd write it like that. Make sure this looks like a nice little R. And then I said, well, now that I see that all of my points are sort of lined up, A prime, B prime, C prime, I realize that the only way for me to move this is a slide, which is another way to say a translation. So I'm going to translate and make sure that you do your x comma y. So I'm translating over 6 and up 2, and that's a translation, and that is a rigid motion. So is this triangle congruent to this triangle? Yes, because a reflection and translation are rigid motions, which will preserve the size and the shape.
All right, now the final 3 questions are very, very similar, especially the first 2. There's a little curveball in the third one, but it says describe a single rigid motion that maps AEB, which is the red one, onto CED, which is the one I outlined in blue. If you notice, you could take this red one and rotate it about the point E, so that would happen. And if you do that, you're rotating triangle AEB about point E such that A maps onto C, or you could say B maps onto D, or it's also a 180-degree rotation around point E. 8 is almost identical. You're taking this triangle here. I knew I was going to get the S there. Hold on.
That's okay.
Not giving up. Not giving up.
You got this.
I'm going to rotate this triangle about point E again. So I'm going to rotate that original triangle, which was GEH, about point E, such that, let's say, H mapped onto F. You could also say so that G mapped onto D. Now the only difference in number 9 is the center of rotation, where you're rotating about. You need to take this triangle, TUW, and you need to rotate it about this point right in the middle, because if you use that point, everything spins into place. So the quickest way to do this is to rotate about the midpoint of WU such that T maps on to V. Now there was other ways you could do that too. You could have rotated around that point, which would have put the triangle down here, and then you would just have to translate it up a vector like that. So there's other ways to do it, but the way I showed you here, you can do it in one step. That's it. Don't forget your calculator, your compass, your supplies,
Ruler,
your straight edges,
a smile.
optional, and we will see you tomorrow bright and early.